Hello, good day, everyone. I'd like to welcome you once again to the ninth day of this AI and machine learning training organized by the College Caucus of the 64th KNUST SRC Parliament in collaboration with GUARD Academy and in partnership with Build It. Today, we are going to talk about machine learning and Python libraries. So, this brings us to the second phase of this virtual AI and machine learning training. I would want you all to pay close attention to what I'm about to teach today because it's going to be an amazing ride. And this particular session is very important because it gives you the knowledge and the understanding you need to know about machine learning and Python library. So today's session would be more of explanation. We are not going to do any thing like coding, right? I'll be explaining what machine learning is and the Python libraries you are going to use for this section of the course, right? So without further ado, let's jump in and get started. When we talk about machine learning, what do we mean by that? Machine learning is basically a subset of artificial intelligence where machines are trained to learn from data and make decisions or predictions without being explicitly programmed for every specific task. So, what's the whole thing about machine learning is that you have a data set, you have a computer. Now, you know that in the conventional way, in the normal hardcore programming, you can actually write a code to perform a specific task. That is what we mean by programming. So when we got to Python programming, I explained what programming is, and we even wrote some codes to do certain things. But here is the case: we want a machine to learn from its surroundings. We want a machine to learn from data, so that in the near future, when we give it new sample data, it will be able to make predictions based on what it has learned. Same thing applies when it comes to natural intelligence, when it comes to human intelligence. You realize that, let's take this as an example. When you are preparing for an exam, you would have to sit down and read your notes. So in this case, your notes, your textbooks, your slides that you are going to read, all the resources is more like the data. Now, what happens is that while you are learning, you are training your brain to more like understand the resources, to understand the data. Do you get it? To draw patterns from it, understand the data, so that when it gets into the exam hall and they ask you a question, you'll be able to make your predictions. You'll be able to make good use of the knowledge you got from the resources to actually give out your answers. So same thing happens for machine learning. You have a data, you train a computer on the computer gets to find patterns in the data, and the computer can now make predictions because it has learned on that. Get it? Good. So in essence, instead of telling the machine what to do, we provide examples of what we want it to do, and it learns to figure it out on its own. That is what we mean by machine learning. Right. So this is going to be a very, very interesting section of this training. And I believe that if you pay close attention to whatever we are doing, you are really going to get a lot of value from this. Right. Good. So let's move on to the next thing we have. We have machine learning versus rule-based programming. So the normal programming we do, what we did when we were working with Python programming, is more of take it as rule-based programming. And machine learning, what I just explained. We are going to look at the differences so you guys get to understand it vividly. Right? So when you talk about definition, rule-based programming relies on manually defined rules and logic. So you realize that, example, when we're working with conditional statements, realize that sometimes you have to write an if statement, an else statement, and all that. So what you are trying to do is you're manually defining the rules. And for the rules to work, you need to follow a specific logic for it to solve the problem. So that is what we mean by rule-based programming. But then machine learning doesn't work like that. Machine learning learns from data without predefined rules. Do you get it? So what you do is you give the computer sample data of what you want it to do. Then the machine learns from it, and in the near future, it can make its own prediction based on what it has learned. So that is the difference between rule-based programming and machine learning. Now we also have flexibility. Rule-based programming, it is hard to scale for complex or changing problems, but then machine learning adapts to new data with ease. So the problem is that for rule-based programming, you realize that it relies on manually defined rules. So if you define a rule that move from point A to point B, it would always move from point A to point B. But then for machine learning, if you give it sample data of how the movement will be, so let's say you give it sample data on how the movement will be from A to B. In some cases, it would have to move from B to A. In some cases, it would have to move from other points to A. So when you give it this variable, this varying data, this machine learning model would be able to figure out the patterns. And then if you give it a new instance, it would be able to make the prediction. So in this case, machine learning can adapt to new data, because while it learns on the previous data, as you proceed and you give it new data, it will still be learning from it. Do you get it? But then rule-based programming is very hard to scale because the rules are defined. The rules are defined. Do you get it? So in the case where we have changing problems, it will be very, very difficult to handle that situation. Good. Now we also have complexity handling. Struggles with unstructured or large data sets. Machine learning excels at analyzing vast, complex data sets. So take a close look at this. You want to build a software which can predict if you have a dog and a cat. So what you do is that for you to make this software more effective and easy to work with or easy to build, it's better you use machine learning, because machine learning would facilitate the process very fast, because the process is easy. You would have to just provide sample images of dogs and sample images of cats. You train the machine, you train the system, you build a model for it, so that in the near future, when it sees a dog, it will be able to make the prediction because it has seen an instance of a dog before. But then if you are using rule-based programming, you have to sit down and hard code, right? Hard code to, it's to me, you are just wasting your time, because you are actually going to write a code to see that this is a dog, this is a cat. And it's sometimes, because it is rule-based programming, if it sees a new instance of a dog, you see the dogs, we have types. We have German Shepherd and then the rest, right? So if you do the rule-based programming on German Shepherd and it sees a new type of dog, it would struggle to make the prediction. But the machine learning, it gives you the platform where you can actually train the model on a vast complex data sets, as simple as ABCD. And maintenance. Rule-based programming requires continuous updates to rules, but then machine learning, it can learn and update itself automatically. So this is why machine learning is really taking over the world, and it's a very essential skill, because most companies are featuring machine learning models in their companies, and it's fast tracking processes, is boosting company value, it's really earning them a lot of money, right? So machine learning is a very great skill. Now we are going to look at a use case which is called this particular use case. We are going to talk about email spam detection. So we are going to differentiate the rule-based approach for solving the same problem, email spam detection, and the machine learning approach. But before that, I would have to explain something here to you. Yes, let me quickly share this with you so we see how we can proceed with what we are doing. All right, so I have another instance where I would want to show you the difference between machine learning and rule-based approach. But in this particular side, I would just focus on let me solve this real quick. Um, okay, sorry for that. I don't know why it's being animated. No. All right. So we are going to talk about something very interesting here. So for you to build a machine learning model, you first need, or for you to build a model that can make a prediction, you first need data. So once you get the data, you now build the machine learning algorithm. Do you get it? And the machine learning algorithm would be able to figure out patterns from the data set. So next time in the future, when it gets new data, you can still pass it through the same algorithm or the same model, and it would be able to find more patterns. But because it has already learned from the previous data, it will still be able to make the predictions. So take this as an example. You want to build a machine learning model that can predict if a patient has breast cancer or not. So what you do is that you get a data set of patients who have breast cancer and patients who do not have breast cancer. Then you train the machine learning model to classify between the patients who have breast cancer and the patients who do not have breast cancer. So based on maybe X-ray images or something, I mean, any other data set. So once you build a machine learning model, it would be able to figure out patterns from the data. And from that pattern, it would be able to make predictions. So next time you have, so currently you have your machine learning model, right? In the near future, let's say from some time to come, you actually want to predict if patients have breast cancer or not. But then you don't have the necessary equipment, the necessary medical machinery to actually make the prediction. So what you can do is that because you already have a machine learning model that can predict if someone has breast cancer, if a lady has breast cancer or not, you can just pass the images through the machine learning model, that same model you built, and then it would be able to what make the prediction. You can also tweak it in such a way that once you provide new data in the future, it would be able to still learn and find more patterns. So it's more like as you keep on passing more data, it keeps on learning and keeps on becoming better. That is how it even applies in, what's the name, human intelligence. The more you keep on training yourself on data, resources, learning materials, the more you become more intelligent. So that is what we are trying to do. So machine learning is more like a branch, a subset of AI, and is all we are trying to do is we are trying to simulate human intelligence in what, a machine form. Get it? Good. So that is it. Now let's take an example. Let's see let's see something. We have a quick analysis here. So let's say this is a normal algorithm, right? This is a normal algorithm when it comes to you. Let's say you want to cook a chicken, right? You want to cook chicken for 30 minutes and you want to also add vegetables. The actual steps, the normal steps you go through to solve this particular problem is simple. When you see algorithm basically mean the structured steps or procedures you take to solve a problem or to build a program. So here you cut the vegetables, then you season the chicken, you preheat oven, and then you cook the chicken for 30 minutes. Then you later on what? Add the vegetables. So when you take these steps, that is when you'll be able to cook your chicken with added what? Vegetables. This is the normal way to do that. But this is how machine learning would figure out this is what machine learning does. So for machine learning, you would give it the input. So this is the input, the vegetables and the chicken. Then you also show it the output. So the output is how the end goal should look like. So you give it the output. And then what machine learning does is that the machine learning algorithm will do is that it would be able to figure out the processes you would have to take to move from the input to the output. So you realize that machine learning, you feed it to the input, you feed it to the output, and then it will figure out the process. But then for the normal steps, you give it the inputs being the chicken and the vegetables. Then you go through the steps before you can cook it. But machine learning, you give it the input, you give it the output, which is the cooked chicken and vegetables, and then the machine learning model itself figures out the steps. So next time when you feed it with a new input, because it has been able to figure out the step, it will use the steps that it figured out to produce the output for you. This is machine learning. Very interesting concept, right? Good. So at this point, we'll move back to what we were talking about, the email spam detection and all that. So when we talk about spam, what is a spam? You quite remember in senior high school, they taught you that spam refers to what? Unsolicited messages. So if you are working with email, so spam refers to unsolicited email messages. So if someone hasn't asked for a message, if the message is not relevant, irrelevant, relevant, whatever is being the case, if the person is not expecting your message and you keep on sending the person messages without the person's consent and all that, it's all it all falls under what? Spam. So now these email systems, because I am having my personal system that does more of I provide email service. It's my business. If you keep on spamming people, it will get to a point I would start losing my customers. Right? I'll start losing my clients. Sorry, I'll start losing my clients. So it is good to have an email spam detection as part of your email service so that you don't get clients who overwhelm other clients with unsolicited messages. So in the olden days, back then, they used to work with the rule-based approach. So the rule-based approach, what happens is that you would have to predefine the rules. Do you get it? Yes, you have to define the rules manually. So if the email contains buy now, mark it as spam. So you can create, what's the name? A conditional statement, right? And be like, if the email that the client is sending contains buy now, mark it as spam. If the email has many exclamation marks, mark it as spam. If the sender is blacklisted, so if the sender, let's say I, Godson, I'm sending a message to Abena. I am the sender. Abena has blacklisted me. So if I am sending the message again to Abena, who has blacklisted me, mark it as spam. So what happens is that for the rule-based approach, you would have to know all the instances of. I was about to make a mistake. Interesting. I love what I'm teaching. Don't mind me. Yeah. So what happens when it comes to rule-based approach is that you would have to know all the cases of spam. Then you write a program, you write a code to what? Mark it as spam. But what happens for machine learning is that you just have to bring in large sample data sets of spam messages, like email spam messages. Then you train the machine learning model on it. So next time, if a sender is sending sample message, because it has been trained on sample data, it will be able to make the prediction that this is spam. So it would what? It would not send. As simple as ABCD. So you realize that the machine learning approach is really effective when you really have a lot of rules, when you have large data sets. Do you get it? So the machine learning approach, train an ML model on historical email data. Do you get it? So let's say you group them, spam versus non-spam. So in the spam column, you can input over 10,000 different spam messages, and then on spam messages, you can input messages that do not look like spam. Do you get it? So the machine learning model will be able to figure out messages that look like a spam and messages that do not look like a spam. So if a sender is sending a message based on what it has learned, it will be able to make the prediction as simple as ABCD. So the model automatically learns the patterns. So words like discount or agent are common in spam. So if it sees a lot of occurrences of these words in the email, it will mark it as spam. So high frequency of links or unusual email structures are also indicators of spam. So realize that usually if those scammers are sending you unsolicited messages, you realize that sometimes it has a lot of links and all that, right? Yeah. So this is what machine learning. This is what the machine learning approach is, right? Good. Now let's look at the challenges. Rules need constant updating. So you see, for the rules, because it is manually written, manually defined. In the case where, let's say you are working, you have your email service business and you are working and you realize that these people now have a new way of spamming people. You now have to what? Write a new rule for that. But a machine learning model would be able, there's no need to define the rules manually. It would be able to figure out by itself. Do you get it? Good. So that is it. And then one challenge of rule-based approach is that it has limited ability to detect new patterns. So example, new spam techniques and all that. It is limited to do that. I explained this previously, right? Yes. And one other benefit of machine learning approach is that it can adapt to new spam patterns over time with updated training. As simple as ABCD. Life is good. Why stress? Now let's move on. Now I just want to show you a simple. I want to use this diagram to explain whatever I just talked about, right? So this is a classifier. So machine learning, there are types. You get it? So this particular one is a classification model because you are classifying if the message is spam or the message isn't. So what you do is that this message, the one in red, is spam. The one in red is spam. But then the one in ash is the normal, the non-spam message. So very good message. I mean, non-spam message. Good. Now, once it is being fed into the classifier, once it is being fed into the classifier, what happens is that this classifier contains the machine learning model that can predict if the message is spam or not spam, non-spam. Good. So once it passes through the classifier will now classify it into either, you see your email, you have the inbox and you have the spam folder. So if the machine learning model predicts it as a spam, the message will move to the spam folder. But then if it is a normal, very good message and it is non-spam, it will move to your inbox. So that is why sometimes when you're watching some videos and even someone sends you a message and you don't see it in your inbox, they ask you to check your spam folder because maybe the classifier could flag it as spam. Get that? Good. So this is what we mean by machine learning. I believe you guys have gotten a basic understanding of it. As we proceed, you get vivid understanding of it. Right. So the last section of today's training is what we mean by Python library. Good. So yes. So Python libraries. When was the last time you went to a library? Maybe when you went to the library, you didn't see a snake. Don't mind me. All right. So Python libraries, very, very important. Before that, let's explain what we mean by libraries in programming. So libraries are collections of pre-written code that provide specific functionality to simplify programming tasks. To simplify programming tasks. Now, you realize that in some cases, as a programmer, whenever you are working, right, it gets to a point where you would have to perform certain functionalities. But because it is very complex, if you have to sit down to write the entire code, it is going to really delay you. So what happens is that the Python community has libraries. So these libraries are already written code that performs a specific function. Do you get it? So when you want to make good use of that function, you just make use of the library. Do you get it? So That is what we mean by libraries in programming. That's what we mean by libraries in programming. Now, they allow developers to use existing models and functions without writing everything from scratch, saving time and effort. So let's say you want to do data analysis. You can use Python for data analysis. But here is the case if you are to sit down and rewrite codes from scratch to perform certain things, it's really going to delay you. So the Python community has libraries where you can just call that library and get access to the tools you can use for data analysis. So this saves you time and effort, right? Good. So there are two types of libraries. We have built-in libraries and we have third-party libraries. Built-in libraries are included with Python installation. So when you install Python for the first time, when you install Python, these libraries come with it. So example is math. This math library is used for performing mathematical functions. You get it. So when you want to work with the how do you call it? The, let's say, trigonometric functions and all those things, you can get them in the math library. We have OS, we have sys, we have datetime. This datetime library is used to handle dates. I mean, yes, how you can handle dates, time series data and dates and all those things, right? And we also have third-party libraries. So third-party libraries are created by the Python community. So when I say Python community is more like um the like the list, not list, the people who make up the the Python space. So if you are a Python programmer and you build libraries and contribute it to for use by other Python programmers, it's more like you form part of the Python community. You get it? Yeah. So you personally, you as a Python programmer, you can also sit down and write codes to build your own library. They get it. People have built libraries for numerical computation. People have built libraries for building, what's the name? Web for web dev frameworks. People have built libraries for scientific operations. People have built libraries for even people have built libraries for pharmaceuticals, where you can import that library and analyze drugs, organic compounds, and all those things. So you can also sit down to build your own library. And for you to make use of this library, because they are third party, you would have to install it. So libraries like Pandas, NumPy, and Matplotlib are third party libraries. So for you to make good use of them, you would have to install the library, and you can now call it, make good use of it. Right. Now, we have the libraries for machine learning. These are some of the core libraries for data handling. So data handling, what I mean by data handling is more of data analysis and data manipulation. So you use NumPy for numerical computations and array operations. So NumPy, py is the extension for Python, and num is comes from the word numeric or numerical. Good. So NumPy is a Python library for numerical computations and array operations. We also have Pandas. Pandas comes from the word panel data. So Pandas is a library for data manipulation and analysis. So whenever you want to manipulate a data or you want to analyze the data, you just have to call the Pandas library and you can get access to its tools. We also have SciPy, which is used for advanced scientific computations. So you can also see SCI. So SCI, which stands for science or scientific, and Pi is an extension for Python. So when you see SciPy, it's a Python library for advanced scientific computations. And we also have Dask. Dask is used for parallel computing with large data sets. Now we also have the main machine learning library. So these libraries are used for data manipulation and analysis. Now we have machine learning libraries. Example is scikit-learn. So scikit-learn is the core library for traditional machine learning algorithms. We have XGBoost, which is used for optimized gradient boosting. We have LightGBM, which is used for gradient boosting for large data sets with efficiency. We also have CatBoost. So these are sample libraries you can use when it comes to machine learning. So you have a model. So you see, one thing is that because machine learning model, you build it on data. When you import the data, you have to clean the data. You have to make sure that the data is in the right state for you to train the machine learning model on. So before you can build a machine learning model, you have to do your data analysis. You have to do your data cleaning. That is why you need these libraries. So when you get to a point where you have to build a machine learning model, you can use sample of these libraries to do that, right? Now we have libraries for data visualization too. So in the phase where you are performing your data analysis and manipulation, it's very good to visualize data. Visualize data, what I mean by visualizing data is more like you creating graphs, plots, or charts. You creating visuals to explain data. You get it? Good. So one thing about data visualization is that it makes explaining data very simple. So assuming you have a huge data set, you convert it into a histogram. Realize that the histogram would really give you the edge to explain it for easy understanding as compared to when they just look at the raw data. You get it. Now, the sample libraries you can use for data visualization, you have matplotlib, which comes from the word math, plot. You get it. So plotting mass visual. Sorry, yes, plotting math visuals. Right? So it's a library for making math plots. So it's a basic plotting for basic plotting and visualization. We also have Seaborn, which is used for statistical data visualization and is built on top of Matplotlib. So this Seaborn library was built on top of Matplotlib. So it gives very beautiful and advanced plots. Right? Matplotlib gives you the basic form. You get. We also have Plotly and we also have Bokeh. Right. So these are sample libraries you can use when it comes to data visualization, when it comes to machine learning, when it comes to data handling. Right. You can also explore other libraries, but then for the relevance of this course, these are some of the libraries you are going to work with. Right. So in this training, we'll look at how to use Pandas. We'll look at how to use NumPy. We'll also look at how to use scikit-learn, Matplotlib, and Seaborn. Because we can't work with all the libraries here. Right. Good. So this brings us to the end of today's tutorial on introduction to machine learning and Python library. I hope to see you in the next session where we are going to talk about how to use pandas for data manipulation and analysis. Before I end, I would like to tell you something. It is very hard to learn a skill. And when you're able to learn that skill, it sets you apart from the normal people. Because for you to build a skill, you need consistency. And if you've gotten to this stage, I would say that you've really done well because you've maintained the level of consistency, you've practiced day by day, you've watched these long hour videos and all that, and you've gotten to this stage. I would want to motivate you that you take this step to finish the course because once you finish this course, you increase your chance of being employed. You increase your chance of being valuable in a company that employs you. You also get the edge to build your own systems, start your own businesses, and make more money. So, this is the motivation I have for you. Keep on going, keep on pushing. If you run into a bug, if you run into an error, if you run into an obstacle, conquer it because the obstacle is the way. I'll take one question from the comment section. Then we end today's lesson. Someone is saying that please won't be needing. Okay, let me just correct that. Won't we be needing a lot of GPU to be able to run machine learning models? Oh, yes. So there are some models that you can basically train on your CPU, right? But then there are some models that they require high computation power. So we would be using Google Colab, where we would connect to Google's GPU to work with that, right? So if I get to that point, I'll tell you that no, don't use Jupyter Notebook because when you use Jupyter Notebook, you are running it on your CPU. But then Google Colab gives you the cloud space where you can connect to Google's GPU, some of Google's GPUs to work, right? So GPUs are quite more powerful than CPU. So GPU stands for graphics processing units and yes, and all that. Right, we'll get there. I would explain that to you as well. Right. So at this point, this brings us to the end of today's lesson. I hope to see you in the next. Until then.